6.3 is about the trigonometric functions of any angles. In 6.2, we used right triangle to define trigonometric functions. This is the angle we used. The angle can be located here or here. So the angle will be an acute angle, meaning the angle ranges between 0 and 90 degrees. That is because the sum of the internal angles in the triangle is always 180 degrees, and this is 90 degrees. So we can conclude that the sum of these two angles become 90 degrees. That means theta, this theta is an angle between 0 and 90 degrees. This time, we want to use the coordinate definition of the trigonometric function. Actually, we want to define the trigonometric functions by using coordinate. We will consider angles in standard position. Angle can be located either in the first quadrant or second quadrant or third quadrant or fourth quadrant. Let's say these are angles. We can think about any angles, but we are just drawing the angle which looks simpler. To define trigonometric functions by using coordinate, we choose a point on the terminal side. This is in the coordinate plane, so we can identify the point with the coordinate. Let's say that is x and y. Then we will draw a vertical line parallel to y-axis. Then we can form a right angle. When the triangle is on the right, on the first quadrant, x-coordinate is actually the length of the line segment, horizontal line segment, and y is the length of the vertical line segment. When we define the trigonometric functions, we thought about the adjacent and opposite and hypotenuse. When we locate the triangle, the angle in the quadrant, the hypotenuse will be denoted as r. That can be calculated by using Pythagorean formula. So r equals x squared plus y squared. Definitely, r is positive. So r is the distance between the origin and the chosen point on the terminal side. We can do the same thing whatever the quadrant the angle is located. We always can draw the right triangle and think y as opposite and x as adjacent. However, in the second quadrant, y is positive, but x is negative. So the side lengths sometimes become negative, depending on the quadrant it belongs to. Let's say the angle is located in the third quadrant, and the point is x and y. We still can draw the right triangle like this. In third quadrant, x and y are negative. In fourth quadrant, when we do the same thing, x is positive and y is negative. What you have to remember here is the y is roughly the concept of opposite side of theta, and x is adjacent side to angle theta. Let's define the trigonometric functions by using coordinate. In the previous page, the hypotenuse r was square root of x squared plus y squared, which is always positive. Sine of theta was opposite over hypotenuse. Opposite is y and hypotenuse is r. And cosine of theta is adjacent over hypotenuse. So adjacent is x and hypotenuse is r. Tangent of theta is opposite over adjacent. Opposite is y and adjacent is x. So it can be defined as y over x. We also defined the reciprocal functions. Reciprocal of sine was cosecant. Cosecant of theta equals 1 over sine of theta. That is reciprocal, so we flip this, then we get r over y. Secant of theta was defined as the reciprocal of cosine function. So by switching the numerator and denominator, we get r over x. Tangent of theta, cotangent of theta is the reciprocal of tangent of theta. So we get x over y. Here is what you have to be careful. What we know is 1 over x is undefined. Whenever fraction has denominator 0, that fraction is not defined. If you look at sine and cosine function, then r is always positive, so there is no problem. But tangent of theta, this denominator, x can be 0 because if the angle is located on the y-axis, then x values are 0, right? When we consider tangent function for a general angle, we exclude that kind of case. So we assume that x is not equal to 0. Similarly, y can be any number. If we just think about the angle, either this angle or this angle, then y value will be 0. When y value is 0, cosecant is not defined. So y is not equal to 0. Here, x is not equal to 0. For cotangent, y shouldn't be 0. What we want to discuss next is the sign of trigonometric functions. Before we move on, we observe something. If you look at sine of theta, that is defined as y over r. What we know is y, r is always positive. So here is y. Y can be positive or it can be negative. Depending on which quadrant it belongs to, the y value of the point in the terminal side will determine the sign of sine. For example, if you think about this angle, then y is positive. So we can say that sine is positive. But if sine, the other angle is located in the third quadrant like this, then y is negative. So we can say that sine is negative because this top part will be negative. Negative over positive is negative. If we think about tangent of theta, if tangent of theta is positive, then y over x will be positive. That means this one plus over plus or minus over minus. Both will produce the number positive number. So we can conclude that when both x and y are positive, tangent is positive. So in the first quadrant, tangent is positive. In third quadrant, tangent is again positive because this one will be y over x, and that becomes minus over minus, which is positive. Let's summarize our discussion. Sine of trigonometric functions. This is trigonometric. FTNS is an abbreviation of functions. As I said, in the first quadrant, x is positive and y is positive. Everything is positive. We can say that sine is positive. Cosine, which is x over r, x is positive, so cosine is positive. And tangent, which is y over x, that is positive. But in the second quadrant, we know that x is negative and y is positive. So sine is y over r, so sine is positive because y is positive, and cosine is negative because x is negative, and tangent is negative because that is defined as y over x, and so this one in second quadrant will become positive y over x, which is minus. In the third quadrant, that is x is negative and y is negative. That implies sine is negative and cosine is negative. We already discussed the sign of tangent in the third quadrant. That was positive. The reason is that was y over x. Y is negative and x is negative, so that is positive. In the fourth quadrant, x is positive and y is negative. So sine is negative and cosine is positive, and tangent, okay, which is y over x, can be written as y is negative and x is positive, so entire thing will be negative, so tangent is negative. So that is the sign of trigonometric functions in each quadrant. Find the quadrant theta lies. Sine of theta is less than 0, and cosine of theta is greater than 0. This is a kind of reversing type of question. This time we know the sign of trigonometric functions, and then we have to think about what is the implication to x and y. I said sine is defined as y over r, and we know that r is always positive. Depending on the sign of y, the entire sign will be determined. That is negative. That means sign of y is negative. So from this information, we can say that y is negative. We do the same reasoning. Cosine of theta is x over r. I said r is always positive. We don't know the sign of x, but entire fraction will become positive because of the condition. So the numerator must be positive. That means x is greater than 0. We have an angle whose x value is greater than 0 and y is less than 0. So that is in the fourth quadrant. Let me write it down again. X is positive, y is negative, angle is located here, so this is angle theta. This is quadrant 4. Let's review the notion of quadrant. This is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. We go counterclockwise. The next problem is a little more complicated because we have tangent. Tangent is less than 0, and sine of theta is less than 0. Previously, we already discussed that a sine depends on the y value, so this implies y is less than 0. We think about tangent. Tangent of theta was defined by y over x. We know that y is less than 0 minus. The sign of x is unknown, but we know entire thing is less than 0. So the only possibility is denominator is positive. That indicates x is positive. In this problem, x is positive and y is negative. So that's quadrant 4. The angle must belong to quadrant 4 to satisfy these two conditions. This is theta. The final answer is quadrant 4 because they are asking you to find the quadrant the angle theta lies. The next thing we want to discuss is reference angle. Let's consider the angle theta is an angle in standard position. Let me just write down the reference angle theta associated with the angle theta is the acute angle formed by the terminal side of angle of the angle theta and the x-axis. What's important to remember here is whenever we think about the reference angle theta, the angle theta is always an acute angle. So the acute theta bar is acute angle. Theta bar is between the angle between 0 and 90 degrees. And another important thing is the terminal side, the angle formed by terminal side of theta and the x-axis. Many students are confused about whether that is x-axis or y-axis. That must be x-axis. We are thinking about any angles, so angle may be in the first quadrant, second quadrant, or third quadrant, or fourth quadrant. Let's suppose that the angle is located in the first quadrant. This is the angle we consider. We want to think about the associated reference angle theta bar. In this case, the given angle theta itself is an acute angle, so the reference angle is the same as the given angle. This time, angle is located in the second quadrant, so this is an angle. Then the reference angle to that given angle will be this angle. This is theta bar. If we want to calculate theta bar, then that will be 100. So this axis, negative x-axis, is 180, or we can say that that is pi. If you add theta and theta bar, then you get 180 degrees. So theta can be obtained by subtracting theta from 180 degrees. If we use radian measure, then we can say that pi theta bar equals pi minus theta. Let's suppose that the angle is located in the third quadrant. This time, the reference angle, terminal angle, and x-axis, so the reference angle will be this angle, this acute angle. This is theta bar. Again, this negative axis plays an important role. This is 180 degrees or pi. This time, theta is the largest angle. This is theta and this part is 180 degrees. So we can say that theta bar can be obtained by subtracting the smaller angle, which is 180 degrees, from the larger angle, which is theta degree. If you use the radian mode, then you can say that theta bar is theta minus pi. If the angle is located in the fourth quadrant, the situation looks like this. This is an angle in consideration. We know that this positive x-axis can be identified with 0 and 360 degrees. When we think about the reference angle, this time we have to think about the positive x-axis. So this is the reference angle. If we add theta and theta bar, then you will get 360 degrees or 2 pi. So we can say that theta bar is the larger angle, which is 360 degrees, minus smaller angle, which is theta. If we use radian, then theta bar is 2 pi minus theta. You will have to calculate reference angles frequently. All you have to do is locating the angle and then calculate it by using this kind of visual. Let's do some examples. Find the reference angle. First example is 100 degrees. I said to evaluate the reference angle, what we have to do is we have to locate the angle in a quadrant. To do that, we have to label each axis with their angle. So 0, 90, this is 180 degree, this is 270 degree. We compare the number to locate the angle. 100 is a little more than 90 degree, but it is less than 180 degrees. So 100 degree is located in the second quadrant. This is 100 degree. Many students are tempted to think about the differences between 90 degree and 180 degree. That is wrong because you're thinking about y-axis. You have to think about the angle formed by terminal side of the angle and the x-axis. That is an acute angle, so this angle is the correct angle. This is theta bar. Theta bar in this case can be calculated from 180 degree minus 100 degree. That is 80 degree. Next example is minus 135 degree. This time we are thinking about the negative angle. So we have to label the angle by going counterclockwise. So negative y-axis becomes negative 90 degree and negative x-axis becomes negative 180 degree. I think this is enough because negative 135 degrees between negative 90 degree and negative 180 degree. So this time the angle is located in the third quadrant. This angle is minus 135 degree. Again, we have to think about the angle formed by the terminal side and x-axis. That angle must be acute angle. So this angle must be the terminal angle, the reference angle. A little subtle point here is the angles are negative angle. And we know that theta bar must be the angle between 0 and 90 degree, which is a positive angle. So to simplify your calculation, what you have to do is just think about the differences between this angle and this angle without negative sign. If you do that, then that is 180 degree minus 135 degree. So that is 45 degree. A little bit tricky part here is even if the angle is given as a negative angle, you don't have to care about negative sign. All you have to care about is the differences between the larger angle and smaller angle. Then you will get the answer. Third example is 11 pi over 8. This time the angle is given with radian mode, so we have to label with radian. This is 0, this is pi over 2, this is pi, this is 3 pi over 2, The angle is given with fraction whose denominator is 8. To compare the numbers, we have to convert all of them to the fraction with denominator 8. So this one is 4 pi over 8. And this one is, of course, 1 over 1 can be written as 8 over 8, right? So 8 pi over 8. For this one, we multiply by 4 to the bottom and 4 to the top. Then we get 12 pi over 8. The number 11 pi over 8 is between 8 pi over 8 and 12 pi over 8. But it is a little less than 12 pi over 8. So we will draw the terminal side close to y-axis. And we identified that as angle 11 pi over 8. Again, even though the terminal side is pretty close to y-axis, you don't think about this angle. The reference angle is always an acute angle formed by the terminal side and x-axis. So this angle is the reference angle, angle theta, theta bar. So theta bar is, we think about the larger angle minus smaller angle, in this case pi, which is 8 pi over 8. So 11 pi over 8 minus 8 pi over 8, which is 3 pi over 8. So this is the final answer. Next example is minus 1.4 pi. This is a radian and negative angle. So the first thing we have to think about is we should go clockwise. This is minus pi over 2, and this is minus pi. This is minus 3 pi over 2. The number in front of pi is the decimal form of the number. So we will fix all of them to decimal form. So this one is minus 1 over 2 pi. So that is minus 0.5 pi. And this is minus 1 times pi. And this one is minus 1.5 pi. So negative 1.4, when we go clockwise, that is pretty close to y-axis again. And this is negative 1.4 pi. The reference angle is this angle, theta bar. The angle which are involved to this is the largest angle, which is negative 1.4 pi. And then we have to think about minus pi. What I said about the negative angle and reference angle, all you have to do is subtracting the smaller angle from the larger angle without the sign. So we will subtract pi from 1.4 pi. which is 0.4 pi. The reason the reference angles are important is because of this. We want to use this kind of right triangle. What we were thinking about is this angle and this angle in the right triangle. Again, this angle in the right triangle and this angle in the right triangle. So we can combine the new definition with the old definition by using the reference angle. But when we do that, we have to think about the sine of the trigonometric functions, which we studied here. Let me write some remark. Trigonometric function values with reference angles those are always positive because I said reference angles are acute angle. So that means positive. And that is less than 90 degrees. What I said previously was we will use this kind of triangle with signs of trigonometric functions on each quadrant to relate the previous definition with the coordinate definition of the trigonometric functions. When we compare the original angle theta and the reference angle theta bar, those will be the same except the sign, plus or minus. This plus or minus depend on the quadrant. Theta belongs to. Sine of theta can be described plus or minus sine of its reference angle, and tangent of theta is also plus or minus tangent of its reference angle. Usually we use this kind of relationship frequently when the angles are related to 30, 60, 90 degree triangle or 45, 45, 90 degree triangle. Let's do some examples. Find the exact value. We want to evaluate sine of 300 degree. We will not use calculator. Instead of that, we will figure out the reference angle and then we will use the reference triangle. This is 0, this is 90, this is 180 degree, this is 270 degree. And this is also 360 degree. 300 degree will be between 270 and 360 degree. So the angle is located in the fourth quadrant. I said we will use the reference angle. We think about the reference angle theta bar. Then the related angle will be 300 degree and 360 degree because if we add them up, we will get 360 degree. So theta bar is 360 degree minus 300 degree, which is 60 degree. I said sine of 300 degree will be plus or minus sine of its reference angle, which is 60 degree. To determine whether that is positive or negative, we have to think about the quadrant the angle belongs to. The sine of sine is determined by the sine of y value. In fourth quadrant, y is less than 0. So that is negative. This became an acute angle, and we know 30, 60, 90 degree triangle. So this is 60 degree, and this is 1, 2, square root of 3. So this one is minus 60 degree. Sine is opposite over hypotenuse. That is minus, opposite is square root of 3 over hypotenuse is 2. So here, this is adjacent because that is attached to 60, and square root of 3 is not attached to 60 degrees, so that is opposite. 2 is hypotenuse. So the final answer is minus square root of 3 over 2. Second question is cotangent of minus pi over 3. This is 0. This is minus pi over 2. This is minus pi. We have to compare pi over 3 and pi over 2. So we have to think about the common denominator. The common denominator is 6. So minus pi over 2 is minus 3 pi over 6. And we know that minus pi over 3 is minus 2 pi over 6. We just multiply it by 3 on the numerator and denominator. So we go clockwise. So it goes less than minus 3 pi over 6. So that's located in the fourth quadrant. And this is minus pi over 3. The reference angle for this one is this one. That is just acute angle between, formed by the terminal sine and positive x-axis. So that can be obtained by forgetting the sine here. So this is the reference angle. Other important thing we have to know is what is the sign of cotangent. To do that, we have to figure out the sign of x and y. X is positive and y is negative in the fourth quadrant. If we think about the cotangent of minus pi over 3, then that will be the same as plus or minus cotangent of pi over 3. But cotangent is defined as x over y, and x is positive and y is negative, so entire sign will be negative. So it'll be negative cotangent of pi over 3. As I said, this one will be always positive. This part will be always positive. Again, pi over 3 is a familiar triangle, which is 30, 60, 90-degree triangle. Pi over 3 corresponds to 60 degrees. So pi over 3 is here. And 1 to square root of 3. This is adjacent. And vertical line is opposite. And this one is hypotenuse. So that is minus adjacent over opposite. So minus adjacent is 1 and opposite is square root of 3. This is the final answer. You don't have to rationalize. The next example is cosine of 3 pi over 2. This time, the angle is located on the negative y-axis. Let's label 0, pi over 2. This is pi. This is 3 pi over 2. The angle is located on the negative y-axis because this is 3 pi over 2. To calculate the cosine function value, we do the same thing we did at the beginning. We will just pick one point on the terminal side. So this one is 3 pi over 2. Then we think about the coordinate. For our convenience, we will choose 0 and negative 1 you can choose like a 0 or any other number like 100, negative 100. But if number is bigger or fraction, then it is unnice to calculate, so I chose negative 1. If we think about the distance between the origin and the chosen point, then that is 1. So r equals 1. So from the given information, what you can say is x coordinate is 0, so x equals 0, y coordinate is negative 1, so y is negative 1, and r equals 1. Cosine of 3 pi over 2 is defined as x over r. So x is 0 and y equals 1, so that is 0. Cosine of 3 pi over 2 is 0. Let's calculate cosecant of minus 11 pi over 6. We go counterclockwise because that is a negative angle. This is 0. This is minus pi over 2. This is minus pi. This is minus 3 pi over 2. This is minus 2 pi. The denominator is 6, so let's convert all of them with denominator 6. Then that is minus 3 pi over 6. This one is minus 6 pi over 6. This one is minus 9 pi over 6 because we multiplied by 3 to the denominator, so we have to do the same. This one is minus 2 over 1 pi, so that can be written as minus 12 pi over 6. We multiplied by 6 to the numerator and denominator. By comparing the numbers, we can easily say that minus 11 pi over 6 is in the first quadrant. This is minus 11 pi over 6. Now we want to think about the reference angle theta bar. This small angle can be obtained by subtracting 11 pi over 6 from 12 pi over 6. So that is 12 pi over 6 minus 11 pi over 6. That is pi over 6. Let's calculate cosecant of minus 11 pi over 6. Then that is plus or minus cosecant of its reference angle, which is pi over 6. The angle is located in the first quadrant where everything is positive, so we will get a positive number. We also know that that is 1 over sine of pi over 6. We are using 30, 60, 90 degree triangle again. This time we are using pi over 6, which is 30 degrees. So we are thinking about this angle. 1, 2, square root of 3. This time adjacent is square root of 3 and opposite is 1. And hypotenuse is 2. So that can be written as hypotenuse over opposite. So hypotenuse is 2 over opposite is 1, which is 2. Find the values of other trigonometric functions. First one is sine of theta equals minus 12 over 13. And theta is in quadrant 4. We have two conditions. Those are sine value and the angle location. Angle is located in the 4th quadrant. So let's just draw a right triangle in the 4th quadrant. Let's go back to the condition about sine. Sine of theta is defined as y over r, and that is minus 12 over 13. What we already know is r is always positive. The entire thing is negative, so maybe y is a negative number, so negative 12 over 13. If we think about the coordinate of this point, then that is x and y, but by thinking about the corresponding part, we can say that y is negative 12, but x is unknown, and r is 13. In the 4th quadrant, x value is positive. To get x value, we will apply Pythagorean formula. Y value is negative, meaning this side length is 12. If we apply the Pythagorean formula, then that becomes like x squared plus 12 squared equals this hypotenuse squared 13 squared. So x squared plus 144 equals 169, and x squared equals 169 minus 144. When we think about the difference, that'll be 25. X is positive, so when we put the square root, x will not be plus or minus. X will be just a positive number, square root of 25, which is 5. By this calculation, what we know is x equals 5 and y equals minus 12 and r equals 13. Let's calculate other trigonometric functions. Cosine of theta is x over r. All we have to do is we use definition and substitution. Cosine of theta is defined as x over r. X is 5 and r is 13. Sine is already given. So let's calculate tangent of theta. Tangent of theta is y over x. Y was minus 12 and x was 5. So the final answer is minus 12 over 5. Let's think about cosecant of theta. Cosecant of theta is 1 over sine of theta. So we think about the reciprocal of this. This one is minus, and flip the numerator and denominator, then that becomes 13 over 12. Secant of theta equals 1 over cosine of theta. So cosine of theta, 1 over cosine of theta is 13 over 5 by flipping it. Cotangent of theta is the reciprocal of tangent, so 1 over tangent of theta. By flipping this, we get minus 5 over 12. Let's do a similar problem. Cotangent of theta is minus 5 over 8, and cosine of theta is greater than 0. Again, we have to think about the quadrant it belongs to. We know that cosine of theta is defined as x over r, and that is positive. I said r is always positive, and so x must be positive to make the whole thing positive. So from here, we conclude that x is positive. And cotangent of theta equals x over y. If you look at this, then y is negative because x is positive. So we can rewrite that as 5 over negative 8. So we use the fact x is positive here to conclude that y is negative from here. So again, the quadrant it belongs to will be fourth quadrant. What is given here is x value 5 and y value minus 8. Now all we have to do is, we have to think about r. This hypotenuse r is 5 squared plus 8 squared. If you use calculator, then you will get 89. And we take square root on both sides, then r is square root of 89. Cosine of theta equals x over r. So x is 5 and r is square root of 89. Let me clarify. X equals 5 and y is minus 8. Sine of theta equals y over r. Y was negative 8 and r is square root of 89. And tangent of theta is y over x. Y is negative 8 and x is 5. Secant of theta is 1 over cosine of theta. So we just simply flip that. Then that will be square root of 89 over 5. And cosecant of theta is the reciprocal of reciprocal of sine of theta. Then that will be minus square root of 89 over 8. Fundamental identities, which I'm introducing here, is something you have to remember very clearly. Tangent of theta is sine theta over cosine of theta, and cotangent of theta is cosine of theta over sine of theta. You have to remember it. If you want to think about y, then it's better to go this way. Let's think about the definition. Sine of theta over cosine of theta can be written as sine is y over r and cosine is x over r. So that can be written as numerator, which is y over r, times reciprocal of the denominator, which is r over x. So these two will cancel each other and we obtain y over x. That is tangent of theta. You can verify this identity similarly. What's important is, remember, tangent of theta is sine over cosine. Then cotangent is automatic because you just flip the numerator and denominator. The Pythagorean identity is very important. You will be using this Pythagorean identity when you learn calculus 2. Calculus 2, when you do integration. Cosine squared plus sine squared equals 1. Tangent squared plus 1 equals secant squared of theta. And cotangent squared of theta plus 1 becomes cosecant squared of theta. I will not verify the identity, but you can just use the direct definition of sine and cosine by expressing those y over r and x over r, and you square those and then add them up, then you will use r equals square root of x squared plus y squared, and you will just simplify, then you will get 1. But I will not go through it. Express sine of theta in terms of cosine of theta. In this problem, we have to relate sine and cosine. If you look at the Pythagorean identity, it says sine and cosine relationship. We know that sine square root of theta plus cosine square root of theta equals 1. We have to express sine of theta in terms of cosine of theta, meaning we have to get sine square root of theta by itself on the left side. We subtract cosine square root of theta, so 1 minus cosine square root of theta. Then sine of theta will be plus or minus square root of 1 minus cosine square root of theta. At the beginning of this section, I said sine is determined by y value. So sine is positive in the first and second quadrant, and sine is negative in the third and fourth quadrant. So we can conclude the problem by writing sine of theta equals square root of 1 minus cosine square root of theta if theta is in quadrant 1 or 2, because those are positive, and sine of theta is minus square root of 1 minus cosine square root of theta if theta is in third or fourth quadrant. Let's do the next example. Express secant of theta in terms of sine of theta when theta is in quadrant 3. If you look at the Pythagorean identity, there is no such Pythagorean identity which directly relates secant and sine. But if you think about the definition of secant, then that is 1 over cosine. What we know is that sine and cosine are related to each other by this Pythagorean identity, sine squared plus cosine squared equals 1. So let's try with that Pythagorean identity. Cosine squared plus sine squared equals 1. We have to express secant in terms of sine, meaning we have to get x cosine squared by itself on the left side. So cosine squared is 1 minus sine squared of theta. If we take a square root on both sides, then cosine of theta will become either plus or minus square root of 1 minus sine squared of theta. We are thinking about quadrant 3. So we are thinking about this quadrant. Sine of cosine is determined by x value. X is negative in the third quadrant, so we have to choose minus here. Now we got cosine in terms of sine. Let's think about secant of theta. We know that secant of theta is cosine of theta. So by doing substitution, that becomes minus 1 over square root of 1 minus sine squared of theta. So the final answer is minus 1 over square root of 1 minus sine squared of theta. Let's do one more example in this section. Express tangent of theta in terms of cosine of theta when theta is in quadrant 4. Again, we try to connect one of the Pythagorean identities, but tangent and cotangent are not contained in one equation. But if we notice that secant is 1 over cosine, in this case 1 over cosine squared, then you can do something with this Pythagorean identity. So we will use this identity. Secant of theta equals 1 over cosine of theta. We decided to use 1 plus tangent squared of theta equals secant squared of theta. Since we want to express tangent in terms of cosine, we have to solve for tangent squared. So tangent squared is secant squared of theta minus 1. But the problem is wanting you to write in terms of cosine. So instead of using the expression secant, we will use 1 over cosine. 1 over cosine squared of theta minus 1. The next step is we have to put square root on both sides to solve for tangent. Tangent of theta will be square root of 1 over cosine squared of theta minus 1. It'll be plus or minus, but in this problem, they are saying that the angle is in the fourth quadrant. In the fourth quadrant, x is positive, but y is negative, and tangent is y over x, so that is minus over plus, which is minus, which is negative, so we will put minus here. Now we want to simplify a little bit more. To do that, we will regard 1 as cosine squared of theta over cosine squared of theta. Let me write it down again. Then this one is 1 over cosine squared of theta minus cosine squared of theta over cosine squared of theta. We can see that we have common denominator, cosine squared of theta. So we can say that is 1 minus cosine squared of theta over cosine squared of theta. So that becomes what? Minus square root of 1 minus cosine squared of theta over square root of cosine squared of theta. This time we can simplify a little bit further because square root of something squared is just the base numbers, which is the cosine. Minus square root of 1 minus cosine squared of theta over cosine of theta. What we know is in the fourth quadrant, x is positive, so we can say that this number is positive. So we don't have to put minus. We have to be careful because square root is of any number will be positive number, but cosine is positive, so we don't have to put minus here. So the final answer is minus square root of 1 minus cosine squared of theta over cosine of theta.